Okay, so thanks for waiting, everyone. As I mentioned, welcome to the AWS User Group for Edinburgh for the month of June. So just to give you a bit of an overview, this is a webinar covering a tool called NimboSH, which we have a guest speaker, and also a talk on machine learning where you don't need any expertise to work on AWS. And for the user group tonight, we're using GoToWebinar. If you have any questions during the proceedings, there's a question box where you can ask in the tab and GoToWebinar that looks like the picture here. And what we'll do is any questions that we can answer during the talk, we will, and we'll have a Q&A session at the end. So eventually we'll be handing over shortly to Miguel, who is doing a NimboSH presentation. And then I'll be coming back and doing the machine learning with no expertise required section of the talk. Then we'll do a quick Q&A and then close out the proceedings for today. So just a quick bit about myself. I'm the professional services team lead at CirrusHQ. We're one of the sponsors of the user group. Also an APN ambassador, which I've recently joined the APN ambassador program. So that's all about promoting the use of AWS in the community and helping people out. I'm a technology enthusiast, so I love everything cloud, but general tech as well. Mostly around things like the games industry and just general developments in tech. I hold 5 of the AWS certifications. I'm also studying for the machine learning speciality one just now. And a few more details there just about my Twitter handle and where I blog about tech on outside of the CirrusHQ. And we have Miguel Jaques joining us today. He's a PhD student from the University of Edinburgh. He's the co-founder at NimboSH, and we'll be going over exactly what that tool is for. He's tech lead at Springbok.ai, and his Twitter handles there as well. So, and what I'm going to do just now is just hand over to Miguel, and he can introduce himself and start going through the NimboSH tool. A second.
All right. Can everyone hear me? All right. Can everyone hear me? Cool. Okay, so yeah, I'm hearing myself. Okay, yeah, I was getting some feedback. Yeah, but now it's good. So you present. 1 second. Just close this. So yeah, I'm Miguel. I'm one of the creators of NimboSH. I don't know why this Google slide is so slow here, but yeah. But so Nimbo is a tool that allows you to do that simple machine learning on AWS. And over this presentation, I'm going to explain a bit more what it is, why did we decide to work on this, me and Joses, a friend of mine, and going to go through a live demo to explain you some of the concepts, so you see the functionality in action. And also I'll have some discussion about kind of why it makes sense and for whom does it make sense to use Nimbo. So first of all, what is Nimbo? So Nimbo is a very simple command line tool that allows you to run code on AWS as if you're running it locally. And what this means is, even though AWS has almost its own paradigm, and it allows you to do many things, working on the cloud still involves a very different workflow from conventional, from just local compute, right? You have to send data to S3, for example. Then you have to make sure your instances are running. You have to sync data back and forth between your permanent storage and your temporary storage. And that's not really how you work locally, right? If you work locally, your data is in a file system. You have the file, you have things always present, essentially, and you have your environments that are already set up. And so we thought that AWS could use a bit more of this simplicity of working, of the way we work when we're running experiments, particularly machine learning, locally. So this tool is focused for machine learning training, and we will have a bit more. I'll show more details as we go. So yeah, it abstracts away the complexity of AWS and allows you to build, iterate, and hopefully deliver machine learning models faster. Now, what does all of this mean exactly? More concretely, so for the programmers in the audience, let's say you have a program, some script to train a neural network on your computer, and you run it like this, right? You do Python train MNIST, for example. You add some hyperparameters and you let it run. Now on Nimbo, we focus on simplicity, and so to run exactly the same thing on a GPU on AWS, you would simply do Nimbo run and add the same thing, right? And so we try to make the design as simple as possible and really abstract away as much of the heavy lifting and the ugly stuff that we can as we can. So why did we even try to build something like this? Well, it's almost a cautionary tale. So I did some part-time work for a company, taking ML projects for some large clients, and at some point I needed to have a neural network fine-tuned within a matter of a week in order to show results to a client, from some standard framework. And like most companies out there, my company does have an AWS account. They do have credits, and my manager suggested I use their AWS account. Well, but as most of you probably know, getting set up on AWS isn't just like that, right? You have to get permissions. You have to understand all of the things that AWS gives you. Do I use the user interface, the web interface, or do I use the CLI, or do I use the SDKs? It's not really. I mean, it's not really AWS's core product. Is not really the amazing user experience. Is the power that AWS gives you, right? You have so much flexibility. You can pretty much build anything you want, however you want it, and that's the beauty of it. But that comes at a cost of complexity. And we thought, I spoke to my friend as well, and we thought that there was no reason why we couldn't just wrap up all the work that has to go into having a good machine learning infrastructure into a small package, right? And so that's what we did. And so we set about automating everything from permissions, instance keys, security groups, syncing your local environment with your remote environment, syncing your local data with your remote data, doing all the nice, neat cleanup when the jobs are done, and writing also a bunch of other very useful functions to automate typical and kind of annoying parts of AWS. So for example, if I just want to check the pricing, we have a command to check GPU pricing, right, on some particular region, instead of always having to remember what G for D dot X large means, right? So we decided, all right, let's try to make this user experience how as if it was built from the ground up, and we'll essentially make our own CLI and abstract away all the AWS code. And so again, just to give a better example, what is the problem with AWS? It's again a very flexible, powerful tool, but it's not straightforward. No one can claim that it's easy to use, or that oh yeah, you just get started and in half an hour you're running things. Well, I mean, maybe if you're using the web interface, it's kind of easy to spin up an instance, for example. But if you're doing this for the first time with code, it's not straightforward at all. So for example, here on the right, you see this endless list of functions. That's not even a complete list. That's just what I could fit in this slide for the hundreds of functions that just the EC2 SDK has, right? In Python. And each of those endpoints has dozens of parameters, right? So none of this is really straightforward, and yeah, so we wanted to simplify all of this. If you add to these functions, if you add, oh, now you have also, you want to move some data around, you have to use the S3 SDK, that's more functions. The user management SDK, that's more functions, etc., etc., etc. So you see, and most of the time, and for this purpose of training machine learning models, most of these you don't need. We can just strip this down to the essentials and wrap them up in a much nicer interface that just makes it much more pleasant and much faster to train machine learning models here. So for example, instead of this, in Nimbo, we have very few functions, very few commands. Each command has at most 2 parameters, 2 arguments. And so you see how we try to make the commands as self-explanatory as possible, divided into kind of meaningful sections. And so yeah, we're very mindful about the functions we put in, and trying to keep the complexity to a minimum. So we have functions. We have a command to run a job, to launch a notebook, for example. Maybe you just want to launch an instance by itself. You just have Nimbo launch. You want to see which instances are active. You just do ls active, right? You want to create some instance keys. You make instance key, right? So it's very simple. I will go through these in more detail in the live demo. But yeah, this already gives you an idea of the sort of things we can do with this. And yeah. Now, you might be thinking, well, but I mean, there's so many alternatives, and even AWS has its own alternatives, like, for example, SageMaker. And I agree that it is an alternative. But once again, SageMaker isn't, at least in our opinion, is not really up to par in terms of that simple user experience, right? It is easier, and it gives you many interesting functionality, particularly on the website, to train your models and deploy them. But again, if you want to use the command line tool, I particularly prefer running programs instead of drag and dropping on Chrome. So, because I mean, if you write your own scripts, you have to automate things. You want to use custom code. Most of the times it's easier. And once you go to the CLI again, the user experience is very nice. There are dozens and dozens of functions with dozens and dozens of arguments. So we wanted once again to simplify that. We do not use SageMaker as our backend. Our backend is pure EC2, S3, IAM, the Boto3 SDK, and yeah, well, just kind of emphasizing that once again. We're trying to stick as much as possible to the process of developing machine learning models locally. Importantly, you don't need to make any changes to your code base at all to use Nimbo. We just package your code, send it to the instance, remove it later, etc., etc. And we'll go through that in a bit. So how does it work in more detail? So in more detail, there is a So in more detail, there's this config file that kind of sets all the configuration for a particular run. And so you can see there are some more advanced options, but these are kind of the most basic ones. So cloud provider AWS. You set a local results path and local datasets path, and then an equivalent for S3. And this allows you to very easily set push data and pull data from your S3, both locally, and this way we know what is the path that should be used when we launch your instances. So when an instance is launched and you run a job, we pull the data from this S3 results path to this path in the instance. So this should mimic your local folder, and this way you have exactly the same structure both locally and remotely, which allows your code to run exactly as is. Then we have a few, very, very simple options, like what's the AWS profile you're using, region name, instance type, whether do you want spot instance or not is simply yes or no. Whether even though if you've ever been through the SDK, there are two completely different functions that behave completely differently. We also have some pre-made images, some AMIs, as they are called in AWS, which come already with the necessary drivers, and it's a very minimal image. It occupies like 8 gigabytes, with all the CUDA dependencies and whatnot. You can specify the disk size, and one thing that you do have to specify, and this is a design choice we made, is the environment that you're going to use has to be specified in a Conda file. And I know that some people are not big fans of Conda, but especially if you've ever trained neural networks, either in TensorFlow or PyTorch, installing those packages through Conda takes care of all the messy, the mess that is making sure that your CUDA versions may match your cuDNN versions, which should match the versions that TensorFlow or PyTorch are compiled to use. And if you've ever tried to do this by hand, well, you'll know what I'm talking about. And if you haven't, trust me, it's very painful to get this right the first time. So we encourage the use of Conda, which, if you're more a fan of pip, you can use pip within Conda. It's the same. But this way, we don't actually have to have all the drivers installed, say all of the CUDA versions installed already in our image, because when we run the Conda installation for your environment on the instance, you will get All right. You will get the necessary CUD and cuDNN versions and all the BLAS, lib things. Yeah, so you have a few other options, like, do you want the job you're running to run in the background, as in we launch it in the instance and then we shut down the SSH session and the job keeps running, or do you want to see it running on your terminal? And for example, if while you're running, you press Control-C, if it's not running in the background, if you press Control-C, the whole job gets canceled and the instance is cleaned up and shut down. So you don't even notice that you're working remotely because it looks so much like working locally. Do you want persistence, as in if the job fails or when the job is done, do you want the instance to stay alive? So maybe you can check some bugs or something, or do you want it to just clean itself and shut down? And yeah, it allows you to also set some permissions and credentials here. So for example, security groups, instance key, and instance role. So yeah, just to kind of summarize so far, we've had Nimbo is a CLI. I will show the CLI in a moment, but essentially everything is controlled by a single config file, and the config file is very basic, and it allows you to do all the things you want. You can, for example, include. We already support environment variables, so you can actually share your config files, and you can put the environment variable directly in the YAML, and it will pick your environment's value. So now, let's see, why is this not working? All right. So in a bit more detail, what is happening under the hood? So for example, if I do Python Nimbo run with the script, Nimbo will do the following. It will launch your instance according to the parameters specified. It will set up your environment in the remote instance. It will sync your local code to the instance. It will pull your data sets from S3 onto the instance, assuming you had already pushed the data sets from your local machine to S3. It will, well, run the script. So in this case, it will execute this command, Python train mnist epochs, blah, blah, blah. And when the job is done, it will save the results and the logs back to S3, and it will do a graceful cleanup of the instance and delete it. Well, depending on the options. Then it's very simple, because from your local machine, you can just do Nimbo pull results or Nimbo pull logs to get the job's results or logs onto your local machine. So you don't even need to SSH into anywhere to check what happened and the results of your experiments. So we also provide many useful commands, which some of which I'll show in a bit. So for example, you want to see how much money you spent, you just do Nimbo spending 3 days or 4 months or 10 months. Nimbo ls prices, it will show you the GPU prices with the types of GPUs, what's their capacity, how much memory the instances have. Very useful. You can push or pull data sets, results, or logs. In here, data sets and results, again, are keywords that are associated with the local results path, local datasets path, S3 results path, and S3 datasets path that are defined in the Nimbo config. ls active to show the instances that are running, SSH instance ID to SSH directly into an instance without even having to know the host the host address. allows you to easily delete an instance. And if, say, you just want to do all the setup but stop before running the job, you can just do launch and setup instead of run. And a recent addition is we also simplify the admin process, because we were finding that users were taking a long time to, it was still requiring some setup from the admin to get a new user up to speed and to be able to use Nimbo, well, in AWS in general. So we also simplified that. Now, enough talking. Let's do a demo and see exactly how Nimbo works in practice. So since I have since I'm running my demo on Linux and this is on Windows, I'm actually gonna be sharing my screen from another computer. Let me share. Okay. This will be fast enough to see. So actually sharing two screens. How do I put this in full screen? There was a way to. Let me just check my layout. All right. Cool. I mean, is this good enough? This is all right. Yeah, I think this is working. I hope everyone can see what's going on in here. Yeah, cool. So, all right. So I'll do a simple example. Let me just get a new window here. So I'm using the please, Laura, let me know if Lauren, let me know if everything is working fine.
Yeah, we can see that.
And if not, cool. Okay, that's great. Okay, then hi. Okay. So yeah, so let's say I'm using an example from one of our example repositories. You'll have more info in the last slide. But so just as here, so what we have here, the main file is a train.py, right? So this is the example that I was giving. We have a very basic TensorFlow code. And this code is straight from the tutorials. It's just uses Keras, has like 20 lines of code, and it trains a neural network on MNIST, right? Now, if I just use Nimbo, wait, I'm in the wrong code environment. Okay. If I just use Nimbo, I can see all the commands that are available to me. So let's think of a very simple workflow. So okay, I want to train this neural network, and I want to see what the prices are at the moment. So I do NimboLS prices, and what this is doing, it's just fetching all the prices with type of GPU, number of CPUs, and memory per machine. So I come here. Maybe I think they are too expensive, so I also want to check what are the spot prices actually of the spot instances, because maybe I don't need an on-demand instance. All right, so G4DNX large, 18 cents an hour. That sounds pretty good, so let's go with that. But before, let me also check how much I've been spending this month. So I do Nimbo spending 3 months just so I get a comparison. Wait. Sorry, I'm in the wrong user. Nimbo spending 3 months, and I get like a very simplified summary of spending on EC2 and S3 per month. Now, I want, I could also do this, for example, 12 days. Let's just see per day. All right, so you see what's going on here. Now, let's assume I want to add a user. Okay, let's assume I want to add a user, and I don't want to go through the whole process of going to the interface of AWS to the console, having to add the user, like having to add the user to some groups, give them all the permissions necessary to run Nimbo. So here we provide a very simple command called, if you're an admin, you're like, you have one of your junior devs is like, oh, hey, can I use Nimbo? And you're like, okay, Nimbo admin setup. This is something you only have to run once. You have to add the AWS profile you're using here. It's also called Nimbo, but I'll have another one called employee. So, and this does everything for me. Most of these already exist, so it's skipping, but essentially it creates all that annoying, it creates the policies, the roles, it attaches the policies to the user groups, it attaches policies to roles, creates more policies, attaches policies, etc., which is something that always has to be done at least once. And now we can just, okay, a user from my organization asked me to use it, so I just go Nimbo add user. Actually, I think there's a small typo here. It's actually my profile and then employee, which is the name of, let's assume, the hypothetical junior dev, right? And so yeah, this just adds user employee to Nimbo user group. This Nimbo admin setup has a bunch of default options, but we can use more options if necessary. Okay, I'm gonna run the rest in admin mode, but essentially, if I could use the Nimbo employee to run any of this, and it would be exactly the same. So now let's check what config file we have here. Well, it's exactly the same I showed you earlier. And some of these have to be set in order to run some of these commands. But if, say, your Nimbo config is missing, the program itself alerts you to, hey, your config is missing, please create it. And you don't need to have all of, for example, you don't need to have all of these fields set up before you say run Nimbo admin setup. You just need like this one. So we try always to get the minimal amount of information. And if, say, you don't have a config at all, you can always do generate config, and it creates like a boilerplate config for you. Okay, so let's just check that we have no instances running. So alas, active. And alas, we have no instances running. If I already have one instance key here to be able to SSH into the instances, but if I didn't, since in the Nimbo config I specified the region I want to use, everything is gonna implicitly happen in this region. So for example, if I would do Nimbo make instance key, it would create me an instance key, download, set the appropriate permissions locally, but it would create it in the appropriate region. And this applies to all of the commands. Okay, so let's do an example here. So let's actually see what happens if I want to run this. Actually, in this script, the data the data is downloaded by Keras here. So I don't actually have to upload it beforehand, but if I did want to upload beforehand, we can do an example. So let's say I want to put something in make. Let's make dear data sets, right? Wait, file exists. Okay, data sets. Let's see. Okay, there's nothing here. I'm just gonna create an empty txt, right? And I'll just add random text, right? Let's say this is our data, tiny data set. Well, we can come here again and we can just do NimboPush datasets. And if we check NimboConfig, local datasets is indeed set to data/datasets. So when I do NimboPush datasets, it will, as you see, it will upload datasets empty to the S3 datasets path. And so now our dataset, our hypothetical dataset is uploaded, but I'm just going to run our script. I recommend using -u so that the output is not buffered. Train.py, and we'll just do one epochs 1. Okay. So this takes a couple minutes to set everything up, as you can imagine. So, but we give intermediate messages about what's going on, right? So, yeah, you can see we're launching an instance with a particular image ID. It gives you the instance ID. Now, there's always this time gap between the instance being ready and it being ready for SSH, which we require in order to set everything up. So we're just holding. Usually, this doesn't take more than 30 seconds, but it can take up to 2 minutes if you're, say, launching in a very far away region, or if you're doing many modifications to your disks or something like that, if you're using some esoteric options. Now, yeah, it syncs the conda, the config, and the setup files. Setup files are kind of internal Nimbo files. It is syncing the code. It always looks for a Git repo, and it only uploads what is in the tree, what is not necessarily committed, but added to the tree. And if not, it uploads all the Python and Python notebook files. That's the default, but we recommend using Git to use so that we only upload the tracked files. Now, so this was running locally, and now this is running. This is the script from the script that's running in the instance already. So this is, since I didn't put run on background, if I had said run on background, anything after this would be invisible and it would just run on its own. But since I didn't, we get to see this in real time. And I could do Control-C at any point here, and it would delete my instance. And that's, I think, is a very neat property that I don't even have to think where it is running. If I stop a job, the instance goes with it, if persist is set to no. So here it's installing the conda environment according to the conda file we gave it. So I can just show you very quickly. It's a very basic conda environment file, just for TensorFlow with very basic dependencies. This is usually the part that takes the longest. But again, you can always set it on background, and if you want to say set it up once and reuse the code and SSH, etc., you can just do launch and setup, and you keep the instance running, and it will be fine. You only have to do this once. But again, it gives you maximum flexibility, because one thing that I'm not a big fan of in some competing services of these ML ops is that they already assume you're going to use one of their environments, but I want a custom environment. I don't want to have to choose their version of PyTorch or TensorFlow. I want my version. Yeah, so this is just TensorFlow gibberish. If we scroll back a bit, you can see here, once the Conda installation was done, it imported the datasets and the results that were already stored from the remote to the now local, as in instance path. And here it starts running the job. So now all of this is output from the Python file. And yeah, so I just ran a single epoch. It was very, very quick. The actual training happens here. And as you can see, once the job is done at this point. Once the job is done, it saves the results and the model to the results path, right? So it does also the data backup as well, finishes the job, backs up the data and the logs, and deletes the instance. Here, the log does not exist because we're not running it in background mode. Okay, so now let's check if we have something new, right? So we want to check our results. How do we do it? Well, we just do Nimbo pull results, right? Wait, it didn't pull anything. Results. Oops. But what happened? Data results. Okay, I'll just remove this whole everything we have here just to make sure it's clean. Okay, yeah. So not sure why the previous one didn't work, but yeah, we have the data here. If we make a change, we can upload it. So we have all the logs from previous runs that I had done. And so, for example, this is the latest model, right? And so if I make a change, say, this works both ways. So let's say, okay, I don't want any of these untitled files here. So let me just, for example, remove this guy, and this guy. Wait. Okay, removed. Now I want to upload to update the remote, because I just do NimboPush results -- delete, and that will delete anything that does not exist. No, anything that does not exist locally but exists remotely. And so if you do it without the delete, it's the safe option, because we don't want to mistakenly delete anything. So for example, yeah, you will see it deleted in the remote. And this works for both the datasets, the results, the datasets, and for both NimboPush and NimboPull. So if something does not exist in the remote and exists locally, and you do pull -- delete, it will delete those files. And so this is an example of how simple it is to use Nimbo here. We can, for example, I can show you for how much time do I have? Okay, 5 minutes. So yeah, we have a bunch of other useful commands. You can launch a notebook very, very easily, and we launch it again. It looks like you're working on a local notebook, but you're actually running on a remote notebook. Oh, I didn't. I'll just launch a Nimbo, for example, Nimbo notebook very quickly, but I'll stop it so you see what it looks like when I cancel a job. And actually, I'll show you, for example, Nimbo ls active, right? So I have an instance running. Now, if I do ls active, you see the necessary details here, when it was launched, the status, ID, etc. And so I'll just cancel this. I'll just do Control C and it deletes the instance, etc. This is essentially it for the demo. I hope this kind of clarified more or less what Nimbo does and how it works and then how easy it is to use. I'm going to go back to the presentation now. Let's stop sharing. I think I can exit this one. Okay. And now let's go back to the presentation for the final 5 minutes. Okay, so now that you have that you've had the technical overview, so why should you or anyone in your organization, or if you're a hobbyist at home, why would you want to use this over something else? Well, if you have AWS credits, particularly, you want to use them. Those are good credits to have, and you want to use them in the easiest way possible. And then Nimbo allows you to do that. So it allows you to iterate faster. The setup is minimal, as you've seen, and you can be up and running in minutes, even faster if you're the admin or of your own account and you don't have other people to give access to. But even if you are in a company or you're a manager and you want to control the onboarding and you have a new engineer and you want him or her up and running real quick, you want them training neural networks on the first day, I think Nimbo really will help with that, because essentially, so for example, one of the engineers that was working with me, he did not know AWS, but he was helping me train neural networks and running some jobs for me using Nimbo without knowing anything about AWS except, well, the credentials file essentially. And so that's the possibility that Nimbo opens, because since it's so close to just local compute and because we abstract away all the AWS lingo, it's very easy even for someone who is not familiar with AWS to run jobs on the cloud. And yeah, so we're always happy to help you or to teach more about Nimbo and help you set up, or if you have any other, if you want to do a collaboration, we're also happy to get on the call with you. And yeah, you can find more info about this and other things on our website. We have GitHub. This code is open source, and we also have some related repositories to help you get started. So yeah, I think that's my time.
Okay, yeah, thanks for that, Miguel. That was really useful. So in a second, I'll move on to the slides that I've got. So, but just before we go over those, question that had come in just on why did you call it Nimbo?
Nimbo is a modification of the word Nimbus, which is a type of cloud.
Okay. Excellent. Okay, so we'll just take back over. Okay. Cool. So thanks to Miguel for the presentation there. So the second half of this user group will be on some of the machine learning services that AWS have that don't actually require any expertise. And as a sort of contrast to all the the code that Miguel just read, these services are available in the console a lot of times, but they also do have the API and SDKs, etc. One of the things I will just say is that some of these are designed as components that you can build into your workflow. So the service itself is not like a complete solution. You may have like extra code that you work around it, but there's a lot of useful services in here. Okay, so essentially Amazon do provide a wide range of different things, more and more every day. In fact, when I started writing this presentation, by the time we came to the user group, we've added a new one related, so we'll come into that at the end. So generally the way that Amazon split things up is they've got three main areas, what they call their AI services. So this is all the different services that Amazon have that you can use machine learning in the background, or Amazon will have used machine learning to provide a service to you. So for example, we'll go through each of these in a second, but the idea is that you don't need to know machine learning to actually use them. So you can have forecasting, you can use Translate, where under the hood is all ML services, but you don't necessarily need to know them. And then they have the ML services themselves. Generally, these are into the SageMaker side of things, but as Miguel's just shown, you can also run a lot of stuff in EC2 as well. But they generally have the ML services under the SageMaker umbrella now. I think there's kind of a change in the last year or so. And then you can actually run different frameworks and infrastructure on AWS, as Miguel's just shown there. So they do support all different frameworks like TensorFlow, MXNet, and PyTorch. A lot of that's on SageMaker. But they also have specific deep learning AMIs and containers, all the different variations on CPUs and GPUs, the different types. So, for example, the inferentia that they mentioned there is the specific EC2 instances that are tailored towards doing the actual prediction of ML, so the actual inference, whereas the training ones are more geared towards the training side of the ML workflow. So what we're going to do in this section is actually go over just the AI services. So these are where you don't necessarily need any ML experience, and you'll be able to get a lot of benefits out of it. So example of use here is for personalize. That's based on Amazon's own experience of running Amazon.com and all the regional variations, and how to recommend different systems to people. So it takes in a lot of data and then figures out what you want to recommend from it. So, and what we'll do is go through each of these different services, just explain a bit about each one. I've got a few examples here and there, but some of them are a bit large to create examples, and some of them you'll see, for example, are industry based, so I don't have a spare factory to test something on. So the first section we're going to go through, sorry, I forgot I added this section in, there's a data science and AWS book that I've used for some of the background of this, and that's where the images of the overall different sections have came from. I'd quite recommend this book. I've been working my way through this myself for the machine learning speciality exam. There's also a practical data science course that's just been released on Coursera, which is a collaboration between AWS and deeplearning.ai. So that's going through a lot of the how to run machine learning on AWS, and a lot of it is geared towards the different SageMaker tools that they've got. So it's teaching you how to use all the CLIs and all the different options that we've got there. So into the actual individual services we've got here. So the first few are going to be on the health area. So Amazon Health Lake is it's essentially a data lake that you can build in AWS, but it's specialized for health related products. So the idea is that you put all your data from different health providers, or like different, say if you work for a company that deals with pharmaceuticals, they may have data from hospitals, from tests, and having everything in one place and being able to process that data in privacy secured ways and in industry standard ways is really useful. So you can use that to identify trends and do predictions. So there's a lot of tools in here that are meant directly for medical. So the health lake itself is where the data would be stored, and there's a few other services that would link in with this for processing of it. But the health lake is specifically uses the data standards from the actual industry as well. So I've put a link here to the NHS FHIR specification. So it's not just an American standard in this case. And one of the other tools you can use with that is the Transcribe Medical. The Amazon Transcribe service itself, we'll come on to later on, is it's a service that allows you to process audio data essentially and from speech. The medical version of this is specifically trained with medical data, so it knows about the structure of medical conversation, so it will be able to create a transcript and say, for example, if you've got a treatment and you're getting a particular drug, then it'll know the names of that drug and how it's all formatted. So the idea is that you process say it's a phone call or a recorded conversation, you transcribe that into text and then you store it in the data lake. The actual process itself is all serverless and there's no data stored while it's doing that. Just at the output, you decide where you want it to go. So you may, for example, want to just store that in S3, or you can store it in the data lake. It also has been trained with expertise in primary care, but also specializations like neurology, etc. So the idea of Transcribe, it knows more about the medical side of things. So it's an industry specialization of the Transcribe service. And similarly, there's the Comprehend service, which is a Comprehend Medical. The Comprehend service is a way of reading through it. The service reads through documents and it understands the layout of a document without you having to tell it. So the idea is that it will understand relationships between different bits of data. So as an example, if you've filled in a form, say you've got there's a section on the form that says name and then you've got your name in there, Comprehend will know that those two things are linked together without you having to tell it. And it will also automatically understand any medical information because it's been trained with a lot of these specifics. So the details of RX norm and a few other medical specializations where it knows the names of things. So it's designed to understand all that and give you that information out, but it's also privacy focused, so you can actually use it to identify any personal identifiable information or health information and remove that from the document or screen it in some way so that you're adhering to different standards, including HIPAA and GDPR. So Comprehend Medical and Transcribe Medical are a way of understanding the data, but you can also then put into a data lake. And so the next section is more on the industrial side of things. So this first one, the AWS Panorama and Appliance. The Panorama part of this is the SDK underneath that allows you to do computer vision locally. So if you have a machine that has a camera attached to it, you can run the computer vision locally, but using all of the Amazon services, much like Nimbo, but this is specific for computer vision. And the idea is that Amazon wanted companies to come up with cameras that have computer vision built into them. So you may have a security camera that allows you to look for site safety, for example. So you can designate certain areas off limits for safety reasons. Say like you're not allowed into this area without a hard hat, for example, and have the Panorama hardware notice those areas and run the machine learning in the background and detect that someone's moved into that area and then send an alert to, you can send it to a phone or any other of the AWS services. You can also do prediction. So in the retail example is where are people actually going in the shop, where are the high touch points on there. So you can use that for various reasons, for stock control or figuring out what your most popular items are, or even where items that people are initially thinking are popular but then they don't buy them. So you'll see people going up but not actually purchasing it, because you could get the stock from how much stock you've actually used. So all the predictions on that are actually done locally on the device, which means it's high accuracy and low latency. And you can also do it when there's no internet access required. So you can set it up in advance and then install it in a factory, for example, where you may have areas where you don't have Wi-Fi. So, and staying with industrial, there's the Amazon Monitron, which I think is one of the best Amazon names. This is for industrial environments for equipment monitoring. So it's not just a service, this one, it actually includes the hardware for the Monitron sensors and the gateway. So you buy those sensors from Amazon. You can actually get them on amazon.com and .co.uk. And the idea is that you put the sensors around your heavy equipment, and it will monitor the vibration and temperatures to predict when something may be failing. So if it sees equipment starting to get hot or vibrating more than it should be, based on previous setup, then it'll notify you on the actual app that comes with it that there are potential issues there. So the idea is to do predictive maintenance then, or it's used to reduce unplanned downtime. So if you can tell when a piece of equipment is going to fail because it starts to vibrate a bit more or it starts to heat up, you can then shut that machine down and fix it before it actually goes wrong, which can obviously cause large bills if something does go wrong. So again, it's all based on the sensors, and then it transfers the data to AWS, and then the service itself actually does the analysis on it based on specific ISO standards, and then it will set up notifications to the app to tell you when something's gone wrong. And the next one, staying in industrial, is the Amazon Lookout for equipment. So this is where if you've got your own sensors or you have your own equipment that can feed back what's happening with it, you can use the Lookout for equipment to ingest all the data that's currently happening, but also take any maintenance records or historical data into account and put all that together and analyze all the different the data that's come in. So you can use up to 300 sensors that run in at either 1 minute intervals or up to an hour, but also the historical data, and it'll take all that together. It'll run a trained model for you, and then it'll give you an output and show you how your equipment's actually running, whether there's a potential issue coming up based on all the different sensors that you've got or the data that you've got coming in. And similar named one's the Amazon Lookout for Vision. So this is a specific example where you can upload images from cameras that you have around, say, like a manufacturing line, and you can use those to figure out what's going wrong. So the example that Amazon have had here is they have a pizza manufacturing line where they want to know if every pizza looks okay and if it's got the right toppings on it. So say, for example, some of the process may have missed out the pepperoni on a pepperoni pizza, and you don't want to send that out to a customer. So what you do is at certain points during the process, you would take an image of each pizza as it goes through, or even a load of them, and then upload that to AWS, and the model will be able to spot any differences. And you can train it from as low as 30 images. So normally with the training data for computer vision, you need hundreds of images. But Amazon have used a lot of sort of pre-built algorithms in the background to reduce that number down. And again, with the pizza, all you need to do is give it examples of what a good pizza looks like and what a bad pizza looks like. So you have a split between sort of good and bad outcomes. Then, and again, you can do it with PCBs or anything that can be identified on as an image. And then what it'll do is it'll take those images as it goes through, and it will use the images to predict whether something's good or bad. And then if it is okay, and you say, for example, all your pieces are going through and you don't find any issues, those will be used to reinforce the first class of the lint to say, yeah, these ones are okay. And every time there's an issue, you can get an email, and that goes into the feedback as well. So if, for example, there's an image that goes through with a pizza that isn't missing any toppings, but the Amazon Lookout thinks it is, and you can identify that as a false positive or a false negative in this case, and that will build back into the model to say, okay, whatever I did to figure out that wasn't an issue, we'll improve it in the future. And so the next section we're going to, so this is a anomaly detection section. I think there's only the one in this. So as I said, we had Amazon Lookout for metrics, for vision rather. There's another service for metrics, and it's a similar service but just for metric detection. So it's not an industry specific one. The idea with this is you can take metrics from anywhere and decide what your good outcome looks like. So, for example, you can build in metrics from, if you've got a booking site, you can know if your sales are going through, find out how many people are getting to the basket, how many people are clicking on your ads, how many are actually completing bookings, all the different key metrics that might be applicable to a business, or might be the ones that they actually look for on their KPIs. You can take all those into Amazon Lookout for metrics and use the machine learning model to actually identify patterns and figure out where things may be going wrong. So it's useful to build in metrics so that not just for like how many sales did they have, but how many people went to the first page, how many people clicked through, how many people put stuff in a basket and then didn't complete, and add all those together, and you'll be able to use the model to decide where things might be going wrong. There are also some connections here, so obviously you can use the Amazon services like S3, RDS, and CloudWatch, but you can also connect into stuff like Salesforce, Zendesk, and Google Analytics, and use those in combination with the other metrics that you've got. So a lot of this came out of CloudWatch, so their machine learning capabilities built into CloudWatch to predict when something may change, so that you can figure out what an anomaly is. But this is a kind of more open ended one where you can use your own metric sources and decide what's useful to you as a business. Okay, so the next section we're going to do is code and DevOps. So this first one is the Amazon DevOps Guru. Again, this is another service that allows you to do prediction and fix things when things go wrong. So the idea with this is you can take sources such as, you can use CloudWatch, AWS Config, which tracks the config of different resources, CloudTrail for the access login, and X-Ray from application traces. And you can use all those different sources together and analyze them for what is normal, and then use that data to then figure out what is abnormal. So if you feed all the data into the DevOps Guru and you know that, say for example, every night your CPU goes up to 70% on one of your EC2s, but that's fine, then that can become your new normal. And you can say, right, okay, when this changes, so you may have a spike in traffic, for example, then you want Amazon to be able to tell you that. So rather than having a straight, once it goes above this amount, then trigger, it learns the different patterns of what you've got. So you can then use that to trigger different services. So it integrates with Ops Center from Amazon, obviously the SNS for notifications, but also other third-party incident management systems as well. So you can directly send alerts to like an on-call engineer, for example. And also some of the recommendations in there are quite good to say, for example, if it notices that your RDS is always maxing out, then it might recommend that you upgrade to the next size. Also, it points out under provisioning, which is one that's not typically used in a lot of metric monitoring. So the idea with this, it will say that if you've got 10 EC2s and they're all not doing anything, then it'll tell you can reduce that number down or reduce the instance size down, which is usually a sort of manual process or a per resource process, but the DevOps Guru should be able to tell you some more of that information. And the next one's the Amazon Code Guru. So Code Guru is essentially a code analysis platform. So the idea is that it can do a review of your commits to GitHub to figure out where you might be going wrong in the code. So some of it will be syntax, but also you can have things like if you've got a Lambda function, for example, where you have a connection to the database and you spin that up every time, do your connection and then spin it back down again. That is one connection per every Lambda run. But if you want to actually run that same Lambda every time someone comes in, you don't want to be spinning that connection up and down every time. And you can share that connection across the Lambdas. So using something like the proxy. And the Code Guru will tell you that. It will say, right, okay, you're using this once, but that might actually be an inefficient way of doing it. So it does a lot of things like that. It will identify code that is inefficient. It potentially can catch security issues. So, for example, if you leave a hard-coded SSH key in your code, it will be able to catch that. It does some recommendations for best practices. So, like when you're using APIs, it's recommended to use connection pooling, doing long polls rather than waiting, using pagination rather than saying I want all the results in one go and getting them a number at a time. It'll recommend those as soon as it sees each of the APIs. So at the moment it supports Java and Python. So I think there are potential other ones coming soon. And it can use GitHub, GitHub Enterprise, Bitbucket, and CodeCommit, the Amazon service. And there are a few other places as well. So you can do some testing in there, but it will also continuously detect on your running your code. So for example, if you are using the profiler and it says that this is a line of code maybe quite expensive to run, then when you run it will actually monitor what's there and it'll say, right, okay, every time your code is run, this part takes 10 seconds, and averaging that across every run that you had, you're wasting quite a lot of time. So it'll give you recommendations for improvement so you can run less time or improve your code in some other way, and that way you're running your execution times lower in production. And this is one where I was saying at the start, there's a new service from Amazon. They've recently launched Bug Bust, which is based on Code Guru. So a lot of the sort of bugs that it will identify, Amazon have created a service that will sort of use gamification to help people fix the bugs that are identified by Code Guru, and there'll be like a global leaderboard. And the idea is that you work towards fixing the bugs in your own code or your company's code, and the more bugs that people fix, the more points that they'll get. And there are prizes that Amazon will give to the sort of worldwide top bug hunters, including, I think there's a trip to reInvent this year for, I think it's the top 10, but there's details on the website of the actual the prizes. So the next section I just want to go through is the Amazon recognition. So this is in computer vision, but this is specifically an Amazon service. The idea with vision is that you can use it to process either images or video and use it at scale. So most of this is done through the SDK. So for example, there's a SDK for recognition in Node.js, Python, etc. And you call the particular function that you want to use, and you can use it to do different things. So you can detect text in images. So if someone uploads an images, you can actually read the text from, say, like a store sign, even if it's skewed or distorted. You can do facial detection and analysis. So whether there is a person in your image. So if you upload a profile picture, you want a person to actually be there. You can also then use that for matching against other users to make sure you've got unique users, for example. You can also detect sort of sentiment of the person's face, so whether they're happy, smiling, sad, etc. And a few other things like sunglasses and whether they have a beard. It can also do PPE detection, which I think is a relatively new feature. So the example that it had was someone wearing a face mask, for example. And also is this video segment detection, which is, it will take a video and it will allow you to figure out where the breaks in that video are so that you can split it up into different areas just for organizing the videos a bit better. I forgot to mention, it can also actually detect objects and scenes as well. So you can actually upload, say, a picture of a city and a tree in that city, and it will identify that it's a city, that there's a tree in the image, and it will label the things that are there. And you can also use it for content moderation. So inappropriate content that's uploaded, you can detect that and then block the content from going through. So I've got a small example on this one. So on the image that I showed at the start of when I was introducing myself, this is where I've uploaded that image to S3. So this is just a snippet of some JavaScript code in Node.js where I've uploaded the image to a bucket and then calling the detect faces function. And what that does, it'll give you a JSON structure back of all the different things that it can tell about that image and a confidence interval of whether it's actually or how confident it is of the value it's giving you. So, for example, the image that I had earlier of my face, I wasn't wearing glasses, so it's 96% confident that I wasn't. I wasn't wearing sunglasses, I'm male, and I have a beard. So there's a lot of extra functionality in there. So we did a previous user group demo on serverless, and we used this recognition service as part of that to identify a photo, make sure it wasn't a duplicate, and whether they're wearing sunglasses or not, because you wanted, I think it was for ride identification, you don't want your profile picture of someone that you're trying to identify to be wearing glasses. So it's useful for that side of things. And onto speech. With Amazon Polly as the text-to-speech service that Amazon use. You might have come across this if you ever use look at the Amazon blogs. Most of the blogs have a Amazon Polly link where it will read the blog out to you. And it's generally a naturally sounding voice. Some words it does get hung up on, but it's improving all the time. So you can use this service to do text-to-speech and then store the output as MP3 or verbose and then distribute it from wherever you need. So again, this is one of the building blocks that you can use. You can also do real-time streaming of text-to-speech using the API. So when you first call the API, it will give you back a streaming link, and then you can feed the text into it, and it will do real-time text-to-speach on there. There are a few different things you can do. So you can give it specific pronunciations and a lexicon, and use the SSML tags, which are specific speech markup tags to decide what the pronunciation of something is, or speed it up or slow it down. One of the real interesting blogs on this is actually from Duolingo, who use Polly as one of their text-to-speech services, and it shows how they do it, because they have text-to-speech for all the content that they've provided. So when you're learning on Duolingo, it'll give you, like, say, a phrase. They've already done the text-to-speech on that, but there are also ones where you type things in and it will do that in real time. So it's quite an interesting read, that one, on how they use it. And statement speech the opposite way, the transcribe of taking audio and video and translating it into text. So again, this is the general service from which Transcribe Medical was the specialization. There are some other industry specific ones that you can add in, but you can also upload your own text. So the idea is that you can say, well, here's all the things that I know how are pronounced based on my industry. Then you can upload them and use that to to improve the underlying machine learning model without you having to then go and recode it. It can also do retraction of PII data, so any particular names, etc. It can actually remove those out, or like dates of birth, etc. And you can use it for content moderation as well, so you can filter specific words out and it will not appear in the transcript. And again, the comprehend is the general service for the comprehend medical. Again, you can do industry specific text here, so this will allow you to do different relationships in the text. You can bring your own terms. So if you've got a specific text corpus that you know that people will be talking about, so the names of services, for example, on Amazon, you can bring that to comprehend, and it will learn to identify how those are said. So it's essentially natural language processing it's using, with some extras in there of how to do the relationships, etc. So one of the other use cases is actually for organizing your documents. So what you can do is you can take a whole bunch of documents that you know are of a particular type, and train the model to say, right, okay, these are what I want to group things into, and then future documents, it will sort of compare those documents using various different machine learning methods to say, I think this document is of type A, or it's of type B, and you can use that to classify your documents into a different structure. So you can use this as part of your workload to say, okay, I've had this document in. Is it a billing statement that I need to look at? Is it marketing text, that sort of thing? And you use different documentation categorization for future use in things like if you've got a support ticket system, for example. And the next one is the translate service. So this is a self-explanatory one. Everybody's used sort of translation services. The specific features here are that you can do dynamic and real-time content, so it can translate as it's coming in. You can then link it in with other services. So one of the examples that Amazon uses is that with the comprehend, it's mostly in English, I believe. And if you've got various documents in different languages, you would use translate to translate them into English first and then put them through something like comprehend, so that you end up with everything in the same language. And translate also supports different formats, so Word documents, PowerPoints, and Excel documents, which I didn't realise until I was researching this that it supported those extra ones. I thought it was just mainly a text-based service, but it can process the Microsoft documents and then translate them as well. And again, you can do custom translation where you give it your own data, so your brand name, anything that's specific to your industry, and tell it how to translate that, so that you're not, say for example, if your company name is based on some common words, then it might translate those differently to how your branding has been translated in the other language. And the next one is Textract. So this is, again, that's kind of related to some of the other methods that we've got here for example, like comprehend. But Textract is a way of getting meaning from data. So you can use this for uploading documents to it, and it will use auto character recognition, but also some other machine learning tasks to understand the structure of a document and extract all the text from that. So the examples that they give here are, if you've got a handwritten, filled in form that someone's got, you can upload that and it will pair like the name that they've filled in and each of the different fields that they've filled in with the actual handwriting that they've written in with, rather than just doing the OCR part of it and just reading the text on there. You can use Textract to understand the meaning behind that and how the relationships are there. And you don't need to tell it what the structure is. So the idea is that you can upload something, it'll process it, and it'll figure out what the relationship is for you. You can also then do to remove any PII data, for example, so you can do for GDPR. And for this one, I've got an example that I used where the course that I mentioned at the top on Coursera. I'd been going through that, and this was a PDF that I'd uploaded that was the output of, it was to do with statistical bias. And when uploaded to Textract, it was able to detect that there was a full table of information and actually extract each different bit of it and how they relate to each other. So, for example, you've got the CI here, this class imbalance, and it's showing you the value in there. And you can see there's 18 different tables in this, but you also get the forms and the raw text. And this is available as an API as well. This was just in the console as an example that I've got there. Okay. And so moving on to the search one. So Amazon Kendra is it's a service that I'd like to use more, but it's actually quite an expensive service for, although it is really powerful. It's essentially a natural language search for the ideas that you upload your entire set of documents to there, and it will read through and understand the relationships of where everything is in that document. So the example here is that someone's searching for where is the IT support desk, and it's understood that it's on the first floor. So it's able to take the background documents, find the relevant information, and just present that to the query that you actually asked, rather than you having to search, find the document, and then find out where in that document it tells you the information. And it's also used for centralized knowledge sharing. So having everything in one place and being able to search for it would be really good. As I say, the only problem with it is that it's quite an expensive service. I think you essentially pay for the processing server to be up and running all the time. So I believe it's $2 to $3 an hour, but there's no real way of turning it on and off. You can delete it, but you can't stop start it the way you can with the EC2. So you would end up paying sort of $1,400 a month, regardless of which version you use and how much you train on it. So it looks really powerful, but as I say, it's quite an expensive service. So it does have industry-specific knowledge. I think this is meant to be like an enterprise search. So you can have industry-specific knowledge, but you can also give different features to it. So you can say if documents come in from a particular source or it's tagged with a specific author, then prioritize that data over someone else. And also prioritize the sort of most recent version of documents in the search results. And so the next section we're going to is just in chatbots. So we get Amazon Lex, which is essentially the chatbot software for Amazon. If you've ever contacted Amazon support and you go through a few different questions before getting connected to an agent, that's Lex that they're using. What it can do is it's essentially a natural language process. Again, it will understand what you're asking it based on the phrases. So you can put in particular phrases. So if someone says, I want to report an issue with my order, then the understanding there will be able to pick out the fact that there's an issue and it's an order, but variations on that sentence will also still work. Excuse me a second. And what you can do from that is then you can use that to automate different things. So in the chatbot example for Amazon, you can ask questions and it will go and get information from your Amazon account, and it will say, is it this order that you've got an issue with? And then you can design the Lex process to say, once someone asks about X, Y, Z, you can then go into different sets of questions. So you can build a tree of chat essentially and respond to different sections. So you can also export that to an Alexa skill and deploy it on Alexa. So you can do the exact same conversations over voice as well. Okay. And it can also be deployed onto mobile, web, and things like Facebook Messenger and Slack. So the different integrations based on the same core set of questions that you set up. Okay. And next one is about personalization. So the idea with the Amazon Personalize is that take all the data that you've got from your customers about what pages they're visiting, what they're buying, and use that data to then build recommendations to them. So again, this is based on what Amazon do on Amazon.com, where if you're visiting specific pages and you've previously bought different items in the past, then it uses that data to show you relevant things that you might want in the future. So there's a few different things that are different on this way. So you can highlight new content if you have something that a customer might be interested in, but you can also use similar items in contextual recommendations. So you can decide which recommendations you're going to show based on what the customer's actually doing at that point. So or where they've come into the page that you're on. And even with brand new users or brand new items where you don't have historical data, you can still do recommendations on that based on sort of it'll be able to pick out particular aspects of the user and try and give sort of more recommendations based on that. Yeah. And next one I just want to go into is the forecasting. So Amazon forecasting is a way of, it's similar to some of the other services, but just specifically for time series forecasting. So if you have data that's coming in that's coming in on a regular schedule, so if, for example, CPU metrics that you know you're getting every 5 minutes, or if you ingest sales data every minute, then you can use that data in Amazon Forecast to predict what the future sales might be. But what it can also do is actually take in related data. So if you know that there's holidays coming up, or there's a promotion running, or even some of the product descriptions of knowing which ones are actually going to sell, you can use all of that in your customized forecasting model, where again you don't need to use the machine learning to train the model. All of the data filters through and is used to combine into a forecast that it will show you in the console, or you can get it in CSV or the API. So yeah, there's 3 ways of getting that, but the idea is that any sort of time series, it will be able to bring it in, and it uses any of the sort of related data to help predict. So one of the things as well is it will use, based on the data that you're passing in, there are different types of machine learning models that it might use, or different algorithms, and it will use, it's actually a service, I think, called AutoML, to figure out which is the best for your data, because not all of the machine models will perform the same on different data. One of them, like if you're using sales forecasting, for example, a particular model might be better for that, rather than say, for example, inventory numbers, because they change at different rates, so there might be different models that are better there. But Amazon will analyze your data and detect which is the best one to use for that. Okay. And the next one I'll just talk about is the Amazon Fraud Detector. So again, this is a service that Amazon have been using, or it comes out of their experience where they've been dealing with fraud for 20 years, and they've got better at detecting that type of fraud, or any type of fraud. The idea is that you feed in the data to it, and it will determine whether a customer is potentially acting strange. If they come through and it's a brand new one and they're wanting to do a large transaction, for example, straight away with nothing else, then what you can do is you can use the fraud detector and force them down additional verification steps. So if you've got users that are displaying high-risk data, excuse me, sorry, high-risk attributes, then you can force an email verification or a phone verification on them. You can also use it to flag any online payments that you think may be fraudulent for human review. So again, this is based on all the experience of different insights that they've found, but you can also give your data to it as well, and use it to further customize it. That's if you've got a customer usage pattern, for example, that Amazon maybe haven't really dealt with before, the more data that you've got there will improve the model for you specifically. So it's generally a good way of spotting this. So you don't necessarily need to use this to then completely block someone straight away. It's just the more high risk the customer's behaving, then you can force them down more routes of additional verification, just to make sure that the valid customers aren't getting impacted by it, because they can then do the verification if they do get caught up in it. But anyone who is actually trying to do fraud will get caught out by that sort of thing. So the last two, just quickly want to go over here, are to do with contact center. So these are two ML services for Amazon Connect. So Amazon Connect is the sort of omni-channel contact center for Amazon. So this is where it will deal with all the different phone calls, chats that might come in. It can deal with emails that might come in. And with Amazon Connect, you build up different workflows. So you can do it you can use it to build up like an IVR, so an interactive voice system, where customers say, I want to speak about my bill, they'll go down a specific route. Or if you want to press option 1 to do this, press option 2 to do that, that sort of thing. So once you've actually built out those workflows and your agents are actually working in Amazon Connect, this contact lens solution allows you to do a lot of ML within there. So you can do analytics of like where customers are going. But you can also do sentiment analysis, so you can figure out, is a customer happy or unhappy during the call. So you can actually figure out, okay, this customer's been unhappy, so we might want to put them through for some extra customer care or call back, make sure that they're okay. You can also use it to read through the transcripts, which are done through Amazon Transcribe, and actually figure out for relevant phrases. So if someone calls up and says, I want to cancel my account or cancel my subscription, you can then set up that for an alert to come through to say, okay, we might need to do something more with this customer. You can also do real-time alerting on that. If detects when a customer is really upset, or they say, I want to speak to a manager, then you can actually send out an alert straight away, and the manager will be notified of that to say there's a potential call coming from here, for example. The real-time transcripts is a quite useful one, I think, as well, for if you've ever phoned up a company and they speak to an agent, you go through all your details, tell them everything you need to know, then you need to get passed to another department. Sometimes you end up either repeating that information, or the agent stays on mute or is talking to the other agent for ages, trying to give you all your information across. But with the contact lens, you can actually do a real-time transcript for that, so that the agent on the other end has all your information from the first agent straight away, and then there's not as much need for any handover there. And you can also do redact any PII data from those transcripts as well, so it'll blank out like date of birth or security information on there. And the last one on here is the voice ID for Amazon Connect. So this is a service for actually identifying customers by their voice and their speech pattern. The idea with this is that you can actually use the fact that you've identified the customer before, that say this is their second time calling, to do different decisions on your actual workflow. So Amazon's example here is, you can say, okay, this customer's phoned up before, I'm 90% sure that it's that same customer, and the last time they phoned up, they already answered all the security questions. So if it goes above a certain threshold, then prompt the agent for less information, for example. And if they're not sure who it is, then prompt them for all of the information. So you can use that to lessen the burden on the customer of doing the identification during every single call, but also have the agents know that it's the same customer on the call, and you can be sure that it's the same speech pattern. So it's not to do with the words that you say, it's to do with how you say it. So it's more like a voice print. So even if the customer phones up and says something completely different, it will use the machine learning to figure out if they are the same voice or not and give you a confidence score. And then in Amazon Connect, you build that into the workflows. Okay, and so that's all the services I'm going through. So at this point, we'll just open it up to any questions that we've got. So, there's Lauren, if you want to come back in if there's any.
Yeah, no one else has asked a question right now.
Okay. Well, what we'll do is we'll just give a few minutes just if anyone wants to ask a question, then feel through. But what we'll do as well is we will, at the end of the user group, we'll be sending out the video of this user group, but also the slides from both Miguel and myself. So all the details will be on there. If there's any of the services, for example, that I've went through that people want to read a bit more about, or for example, the GitHub link for Miguel's NimboSH. So cool.
Also, in the email that will go out will be a customer satisfaction survey. If people don't mind taking the time to fill that out, that'd be greatly appreciated. Thank you.
Yeah. So that is actually what I just mentioned is on that side. So we'll be putting the presentation and the video up on the user group website, and the link here is for the satisfaction survey as well. So just to give us some feedback on how things have went, or if there's any future topics, for example, as well. Okay. So yeah, I don't think there's been any more questions in.
No, nothing yet. If anyone does have questions, you can feel free to contact us through the meetup organisers. John and I are both on there, so we'd be happy to answer any questions if anyone comes up with something later on.
Yeah, absolutely. Yeah. Okay. So I think what we'll do is we'll leave it there, and it's just thanks for joining us, everyone, and I hope you enjoyed the two presentations and got some good information out of it. So thanks, everyone, and we'll see you hopefully at the next user group.
Thank you.
Thank you.